Now we would like to begin 5G, 6G special day 2, Evolution and Development of 5G and Local 5G, Session 3, Further Development of 5G with mmWave. First, I would like to ask Mr. Masakazu Shirota of XGMF Qualcomm to explain this session and deliver his presentation. We have simultaneous interpretation service in place during this session. Please use the receivers distributed at the reception. Channel 1 is for Japanese, Channel 2 is for English. Mr. Shirota, the floor is yours. Thank you for the introduction. I am the co-sub-leader of XGMF Odaiba X Core project. My name is Shirota. This is the final session of the day. We will be focusing primarily on millimeter wave related activities. Since the inception of 5G introduction, millimeter wave has been available in Japan, but we haven't really seen a quantum leap. Today, we would like to discuss how things have changed through the presentations by the speakers. Millimeter waves gradually are expected to evolve going forward. Today, we have 2 presentations to deliver from XGMF, followed by presentations by AGC, Sumitomo Electric, KDDI, together with KYOCERA and NTT DOCOMO. Various speakers are joining us for their presentations. Please look forward to them. Now, I would like to begin my presentation. Now, let me begin. Once again, I am the co-sub-leader of XGMF. My name is Shirota. Today, within the Odaiba X Core project, I would like to highlight the activities related to millimeter wave. XGMF is a project and project-based forum, and there are various projects related to 6G, millimeter wave, local 5G, and so forth. There are currently 20 projects related to these topics. The development of 5G, primarily focusing on millimeter wave, that is the focus of Odaiba X Core. Odaiba X Core project. The project leader is Mr. Nakamura of NTT DOCOMO and Mr. Iwanabe of InfoCity as the co-project leader. And then there's myself and also Mr. Takano of Beat Media. We have the leaders of ICT and from the upper layer, so to speak, we have attendees joining this project. Formerly, in 2023, 5GMF, which is the former XGMF, created an ad hoc for millimeter wave, and that is how Odaiba X Core project was formed. And the right-hand side is the media called Telegraphic, and we are supervising this media. They are featuring articles about our detailed activities. So I hope you can sign up for their newsletter, taking this opportunity. And this is our promotion, but XGMF is well, we have an industrial 5G related body, 5G ACIA, and we have an MOU with them for a collaboration. So this is not a forum to discuss millimeter waves per se, but millimeter wave is utilized for some of the solutions. And on the 4th of December in Odaiba Nihon Miraikan, there will be an event co-hosted by XGMF and 5G ACIA. and also FFPA. So millimeter wave related activities are put together in this white paper. There are 10 chapters in total, starting from the necessity for millimeter wave, trends in Japan and overseas, frequency allocation, and actual solutions. Use cases are also featured in one of the chapters. In this January, the latest version was released. I hope you can check the white paper. This is in English on the slide, but we also have a Japanese version. Today, what I would like to convey is when we were developing this white paper, we also organized our ideas around challenges related to the use of millimeter wave. One is a limited area. Second is the limited type and quantity of terminals that can be connected, and also lack of use cases for millimeter waves. These challenges, 3 challenges, are interacting with each other, creating a negative spiral, ending up in doing no project. So after my presentation, there will be a presentation about one of our projects utilizing millimeter wave. And in terms of the media, KDDI and DOCOMO, the carriers, will be presenting during this session. And in our past discussion around millimeter wave, I believe there were only very limited occasions where mobile operators discussed about millimeter waves. So starting from today, I believe the trend, the situation will start to change. And through these series of changes, we will be able to convert this negative spiral into a positive one. That is something I'd like you to feel throughout today's session. And this challenge itself has not been resolved yet. Regarding millimeter wave, technology-wise, I believe we can call this mature. We have base stations, terminals, and with radio waves, it can demonstrate a very high performance, and there are many supporting technologies, which I'm not going to elaborate on today, but please check our white paper to learn more about the detailed technologies, and some of the technologies will be covered during today's presentations. This is a summary. As I mentioned earlier, the negative cycle needs to be transformed into a positive growth. As XGMF, to that end, we will be providing information, and if there are actual use cases, we will be sharing them so that we can create changes. And of course, we need connected areas, but using beamforming and using repeaters, we will be able to transmit signals, and if we need higher capacity, we would need base stations to be installed. And in terms of regulatory support, this is of course necessary to enable high power terminals, and we may need to allocate higher frequency too. And we need cross-industry collaboration. As the mass market, mobile phone is the biggest market, but millimeter wave utilization in other areas also need to be pursued. So experiencing millimeter wave, experiencing its incredible performance. I believe some of you have smartphones that support 5G connection, and I think you understand the outstanding performance and why it is necessary. And we also need to pay attention to human resource development and education. In Odaiba X Core project, almost every month we are holding workshops. The yellow highlighted ones, I apologize, the letters are tiny, but these highlighted workshops are related to millimeter wave. The most recent ones, including the one in November, will be an occasion for the audience to experience millimeter wave. In the beginning, we were explaining the concept of millimeter wave, but recently we are moving more towards experiencing millimeter wave performance. That concludes my presentation. Thank you for your kind attention. Thank you, Mr. Shirota.
Next speaker is also from XG Mobile Promotion Forum. The title is the project leader of the Supporting One's Fave X5G project leader. He's from a Murata Manufacturing Company Limited. He is a principal engineer at Corporate Technology and Business Development Unit of the Next Generation Telecommunication Business Development Office. Mr. Daijiro Yoshii is to give explanation or presentation under the title of the potential that we started seeing after trial and error. I'm sorry that my title is quite long, but I would like to talk in the capacity of the project leader of the Supporting One's Fave X5G project leader. So once again, I'm the leader of the project. I can't really see this room, but who have a good sense of what FAVE supporting activities mean? Could you raise hand if you have a good idea? About 30% of the people. So I think it's good that I had this term of FAVE supporting activities in the slide. I do not really have the information about FAVE support activities in this slide, but I understand that the FAVE supporting activities now has a grand market equivalent of 3 trillion yen, which is about same as a beverage, alcohol beverage. Now this is the agenda, starting from explaining the XGMF and Murata Manufacturing. So I work for Murata Manufacturing, and I'm not going to I'm going to skip the detail of the XGMF. But on the right-hand side of this slide, there is the policy of our company. So the policy says that the company intends to contribute to the cultural development of the culture, and this is a point that connects me with the company, and I do believe that the technology that we're talking about is with the potential to contribute to the FAVE supporting activities culture. And that's the idea that I'm going forward with. So what do I do? So this year, I've given opportunities to give lectures and also write articles. I only work on the millimeter waves, and still I'm giving this opportunity to share my insights. And I'm working with many partners, and I work with the Sexy Chemical or KYOCERA. And I've been holding events, gathering about 50 people. And most of them are workshops to spend a day and a half working only on millimeter wave. Often we discuss the challenges that the people of different companies are having in relation to the millimeter wave. And there have been many ideas generated from those occasions, which I'd like to share today. And one of the media I work on is the telecommunication. How many of you have read them? Business Network is the web media. Have anyone been exposed to this? Yes, I see more hands. So on the September 25th, there was a October edition of the Business Network being released, and there is a serial article on the millimeter wave. millimeter wave is often talked about in the negative context, saying that not much success have been materialized. My intention is to send out more positive communication message in relation to the millimeter wave. Otherwise, we won't get any positive feedback from the generative AI. So the first installation of the serial article featured myself and my colleague. And going forward, we like to have a contribution from those at the carriers or from the authority or government. And so there will be enough ideas for the coming articles that allow us to keep going until next April. Last week, we had an article on the business network, which was to do with the Expo. In the Expo venue, the millimeter wave was used, and the article featured what was interesting in relation to that initiative. So we like to continue this regular column. So if there are anyone who would like to contribute, please do contact me so that we can continue this project. Now, this slide is the same chart from what Shirota-san presented. There is a URL for the white paper, so if you are interested, please take photo. So this is the Japanese version of the slide. There are three elements for the millimeter wave to demonstrate its full potential. So in a balanced manner, all those three elements need to be developed. That's been mentioned for a long time, but I feel some discomfort seeing this chart. And my question is, which element is most important? It's easy to say every element is important, but for me, application or the use case is the most important. In other words, can this lead to profit is most important because companies are, after all, profit-generating organizations. And this is exactly the element with the highest difficulty level. But there are many potential ideas for generating money. So I think the priority should be given to the development of the applications or the use case. And there are carrier players who are working intensely on the area or basis, but I think the most challenging element is the use case or the applications. Now, let's look at this in the historical context. This table is the outcome of the response from the generative AI. You hear often about the 6G, but in the 6G discussion, it's often said that we should never repeat the mistakes we made with the 5G. So what is often said is that there was a failure of monetization in relation to 5G. This point is what I was not comfortable understanding, so I asked question to the generative AI what this is about. And then this question was analyzed from different perspective. And when we looked at the changes from 2G to 3G to 4G to 5G, there are major changes happening in the transition from 3G to 4G, meaning that the carrier's position were changed from the 3G to 4G, from vertical integration to the pipe provider. So this is not me saying, but this is the response from the generative AI. But I felt that this major shift occurred in the transition from 3G to 4G, and also with the much application being implemented, there were major change after transition to 4G. With the much success in the monetization with fixed rate data plan and such. And most of the data are for the commercial usage. But when it comes to 5G, who is to drive monetization? For the monetization model for the 5G, the question raised was, what is the appropriate unit price? You can sense that the typical cost is rising, but that is not the case for the communication or the fee. I think because of the infrastructure investment of the carriers, we are not feeling much frustration in terms of the quality of service being provided. But are we paying back to those carriers for their investment? That is something that I've been wondering. Now, for the millimeter wave to be adopted widely, we need to achieve the goals, and one of which is always connected as nothing special. And for this to be promoted, what I think is important is to see the change in the evaluation metrics. Currently, only the radio wave aspect is being evaluated. This is what I carry around myself. These are the 4 units of the millimeter wave equipment, and I have 4 of them so that I can analyze the exclusion in relation to the 4 carriers. And on the top right, or the left top, you can see the aspect of the radio wave. For the radio wave, the measurement can be done by the number of the base stations or the population coverage. But for the other aspect, other than the radio wave, are not appropriately measured as I see, and there are no appropriate indicators as well. Now, I'd like to share with you with the episode. For example, in this kind of a venue with a large number of the spectators, in terms of the radio wave, there are good figures shown for with regards to the indicators, but the user experience is poor in often the cases, and so we need to make change for the infrastructure needed for provision of the service using millimeter wave. And I do believe that I be needing to talk with the carriers, but I need to be talking not only with 1 carrier or 2 carriers, but I need to have a industry-wide discussion over what kind of indicator would be appropriate to measure the user experience. And I believe that the millimeter wave adoption will be made possible with the establishment of the appropriate indicator to measure user experience, or that is relevant to user experience. Now turning to the second pillar of the usability, or being usable. We have the URL here. And so you can have access to the data here. And at the expo, which closed 2 days ago, we have a millimeter wave environment, and we tested the video streaming transmission with the 4K quality. Even with so many people being here, we were able to use the millimeter wave for uplinking the video. And I was there 6 hours, but I made a misconfiguration, so the bitrate was not appropriate for 4K. So the image is not as high quality as possible. And other than that, this is the situation of the venue for the live performance. Even with the 50,000 crowd being there, utilizing a millimeter wave, we can uplink high quality video, which leads to a possibility of the monetization. Now, about the future. The idea is to start small toward the monetization. In Japan, as described here, in total, we have the 2.5 gigahertz of the 5G millimeter wave band. And if we are to monetize as of now, we need to be considering the business model to start with one carrier with a 400 megahertz. So what can be done? What kind of user experience can be provided? And to how many people can service be provided? And what would be the revenue raised per person? Those are the questions that need to be addressed. And in order to address this, what kind of indicator should be used, and the hint can be given by considering the FAVE supporting activities. And by monetizing with combination with the FAVE supporting activities in collaboration with consumer activities, we'd like to come up with a business model. Now, conclusion. So there are three elements for the millimeter wave to demonstrate its full potential, but I believe that one of those three, the use case is the key. And who is to drive the monetization is a very important point. And if no one is to raise hand, I like to take lead. And also, what is important is to ensure the contribution to the user experience, and the millimeters waves a large uplink capacity is suitable for live video streaming. And we like to come up with the business model leveraging this aspect, and I'd like to work with a potential partner who is interested in this possibility. And that concludes my presentation. Thank you very much. Thank you very much, Yoshii-san.
Next, we'll have a presentation from AGC. We have Mr. Osamu Kagaya, who is the sub-leader in electromagnetic wave team at Functional Member Department at Material Fusion Research Institute at AGC. Thank you very much. I'm very happy to be able to talk about the possibility and potential of the spatial electronic magnetic wave control for glass members. So first of all, let me introduce my company and myself very briefly. We are located in Tokyo. However, our research center is located in Tsurumi Ward in Yokohama City. From basic research through material development and also production engineering are all located in this place. Now, for myself, my name is Kagaya, and in 2001, I joined Asahi Glass. That is the former name of the company, and I have always been working in the Central Research Institute, and ever since the entry into the company, have been working on the glass antenna and electromagnetic wave scattering and others. We are a glass company, so you may be wondering why I'm studying electromagnetic wave. So here's the background. Now, in our company, our company started to work in the research of electromagnetic wave domain in 1970s. Initially, it was the development of the automotive glass for AM/FM receiving glass antenna. And based on this experience, designing antenna was also part of the work now. And of course, we now study the research, we study the materials of the antenna and glass. And also we study microwave itself. Today, I would like to talk about one of the research items these days. Now, it's not only limited to automobile. It can be also about buildings. We provide glasses. When it comes to glass windows, a glass window is actually a wall or border material that separates inside and outside of the space. And so we use the meta-surface technologies in glass windows or the window glasses. So I would like to specifically talk about these underlying technology in this area. First of all, now glass has the reflection functionalities and also transmissions functionalities, and there are different features too, like it can curve and not. Now we have transmissive glass, so we would like to talk about that first. This is called wave through. Now, in case of building glass, you may not know how these are structured. In case of buildings or condominiums, often there are composite glasses used in sash. And in between two sheets of glass, there is gas, argon glass. We call it composite glass. In this kind of glass, the purpose of this design is heat isolation, and it is widely used. This is double glass, so we have inner glass and outer glass. In order to increase the heat insulations, outside surface of the outer glass has silver coating, and this kind of glass is called as low emissivity glass. And so this is the silver coating, and this isolates. This actually has the silver coating on the surface. So in case of this low E composite glass, the radio wave is blocked by this glass. I'm sure you have experienced that inside of the building, inside of the glass, you have deteriorated radio wave. So to solve this, we have this product called wave through. Part of the coating is removed by laser processing, and so that the radio wave can go through composite glass of this type. As you see at the bottom, in case of coating glass, there is a signal loss of about minus 30 decibels, so it's quite significant. But if you have this wave through processing, it can be improved, and so the signal loss will be limited to minus 5 dB. And also light transmittance, there's no difference. And also U value thermal transmittance, there is no impact. The performance of heat isolation of the composite glass is not deteriorated. Now, this is another case. This is about the reflection, and we call the product RadioVia. And it is the product is transparent resin panel or glass plus the metal membrane, and having a specific processing on this metal membrane, you can use it for the and this product is often used for safe guard or shield or the sound barrier on highways. It can be used as a partition within a space, and it can be used as a safeguard fence within a plant. But also, this product, RadioVia, can improve the radio propagation environment. One of the topics these days in our research activity is, again, about the reflection. The reflections can be different types. One is anomalous reflection, which reflects like 45 degrees, and we create a specific reflector that has that anomalous deflection of 45 degrees. And reflector A on the right side in a graph, which is shown with the blue color, has 45 degrees anomalous reflection, and reflector B is scattering or diffusion type, and then that is indicated with orange color. And then if there is no reflector, then you have the solid dark line. This is another case which is done outside of the building. And you see we placed a reflector on the left stop, and then the red arrow on the graph shows the light injected from the front, and the reflection is about 70 degrees, and the peak reflection is at 70 degrees, which you can see in the graph on the right side. Now, I talk about reflection and transmissions, but this is an example of warping wave. This is a metasurface or transmissive metasurface. It's a kind of transmissive type lens for radio wave. As you see here, often the base station, maybe you don't have a lot of base station within the building, but let's say when you want to have base stations in buildings, normally it is located at the top ceiling or the top roof, sorry. And then at the result, at the bottom of the building, there are some space where you can't receive signals. And in this case, we were assuming the base station was located within a building and tried to remove any signal, no signal area. This is the building that we used, which is actually belongs to the partner. And there's a sash, and then there's a metasurface glass in the window portion, and the radio wave is emitted from inside. And then we try to see how much signal improvement can be observed. And the red one shows that the electro field was improved. And you see that there's a reddish portion just next to the building, which shows the improvement. And also you can see the throughput improvement. So there has been significant throughput improvement, as you see here. Another example. Now we talk about transmissions and reflection and reflections, and this is about the absorbance. Basically, this is again using metasurface technology, and this is a case of laminated glass. Basically, two sheets of glass are sandwiching the intermediate layer of resin, and then this blocks specific frequency. This is not a case of millimeter. 90 megahertz area, 900 megahertz area was an example. But of course, we can do the same thing with millimeter wave if you just change the design. This is RFID. So this is a case of RFID tag reader. And let's say on the left side, you see the RFID detector. And the issue was, now, on the right side, we see the case of using a wave trap AS. On the left side, we see regular wave reflective panel. As you see at the top, you might think that the left top shows a good condition because it's red. But if it is 0, 1 is opposite, then the you see it is shown at the bottom. So this means that even if the RFID tag is not scanned and yet the wave can be detected, that is bad. So if you see on the right side, green is 0, and green is 1, and orange and pink is 0. So this means unnecessary wave can be removed. And again, this is using metasurface technology. And we have designed and we are manufacturing this today. So I talk about different glass technologies. Again, glass window is the border material that separates inside and outside of the buildings. Using metasurface technology, we can do many things. We have developed necessary underlying technologies. Using metasurface technologies, we can design transmissions, reflections, absorbance, and refraction. So far, as it was indicated in previous presentations, we are looking for use cases. And that is something that we're exploring today. That is all from me. Thank you. Thank you very much for your attention. Mr. Kagaya, thank you.
Next, I would like to invite Mr. Hiroshi Miyata of Sumitomo Electric. Dr. Hiroshi Miyata is a Senior Assistant General Manager of Information Network R&D Center of Wireless System Department. Thank you for the introduction. My name is Miyata of Sumitomo Electric Industries. Today, I would like to introduce SEMIDAS, a distributed antenna system supporting mmWave. I would give just a brief introduction of our company. Optical cables and electrical cables are what Sumitomo Electric is famous for. But as you can see, we also have broadband network systems, and electronic devices, gun device used in base stations. We also manufacture and sell these products, and also has acquired a meaningful market share. Today, I would like to introduce our mmWave solution, SEMIDAS. Now I'm moving on to the main topic. Please look at the left chart. This is showing the increase in mobile traffic. 5G started in 2020. We're now in 2025. And since 5G started, the traffic has increased already by 3.8 times. And this increase will continue. In 2030, it's expected that we will run out of frequency. Some industrial bodies have already issued such warnings. And actually, we are already starting to run out of frequency band. But when we look at the current status of frequency, mmWave and sub-6 and below, although it says 7 gigahertz on the slide, we have confirmed the frequency allocation in Japan. mmWave already accounts for over 50%, but as it has been explained, this is not fully utilized. So before running out of frequency, we need to better utilize mmWave. I believe that makes a lot of sense. And indoor, 80%, that's what it says on the slide. 80% of mobile traffic is consumed indoor. That is what is said statistically. And I'm sure you're already familiar with this, but mmWave is difficult to travel from indoor to outdoor. So I believe that is the reason of this impression that mmWave is inconvenient. And in order to achieve a breakthrough, we have been developing a distributed antenna system. When you hear distributed antenna system, maybe some of you are not familiar with the idea. This blue area is the base station. Radio wave emitted from base station is received, and it will then be transferred to the destination through a wired connection. And because it is carried through wired connection, it can offer better reliability as it can carry multiple radio waves This is an existing technology that has been used for long, but when we try to use this for millimeter wave, we still have a couple of challenges. First is when we try to extend the distance using wired connection using coaxial cable, we will only be able to extend by a couple of meters. And radio wave from RU, well, beamforming is normally used for millimeter wave, but when we try to do beamforming, radio wave from RU doesn't have control signal, so we cannot conduct beamforming on the antenna side. We have tried to cope with these challenges so that we can better utilize millimeter wave. That is what our SEMIDAS is for. So what is SEMIDAS? Today I'm not going to talk about its technology, but please remember this term, analog radio over fiber. This is a technology to carry analog signal above the optical fiber, which enables long-distance extension. And semi is a Japanese word for a cicada, so it is representing the size, the small size of the product. This is how small it is. It is 10 times 10 times 6 centimeters. And this is a benefit, one of the benefits from using analog ROF, but it is very compact and it is very energy saving. And the volume compared to the conventional one is 1/10 of the size, and also it requires very low power for operation. And monopole antenna is used, which is a quite unique solution. When you hear millimeter wave, I think you have this formula. Millimeter doesn't travel, so it requires beamforming, and thus you need the antenna. But we decided to design a DAS dedicated to indoor use, so we concluded that monopole antenna is the best solution. Well, but that said, I think you cannot be assured if you haven't experienced this solution. So I would like to explain the ability of millimeter wave and monopole antenna. The left chart, this is the ceiling. In the middle of the ceiling, we will install this antenna, and then this pumpkin-shaped radio wave will be emitted toward the lower space. This is a pumpkin-shaped radio wave, and in the simulation, I would like you to imagine a 20 square meters room. Downlink is 600 megabps in the middle, and 400 megabps at the corner of the room. That is the speed. And uplink is above 80 megabps and 40 megabps respectively. These are simulated values, and later I will show you the actual values. When we talk about using millimeter wave indoor, we are always asked about the impact of fading. We have measured the influence of fading. This is a 100 square meters room. The top is the simulated value with 1 and 2 antennas respectively. And if you look at it from the top, this is the theoretical value that the strength of radio wave will diminish. And what this means is that this model is not taking into account the impact of fading. And the bottom is the actual value. When we look at both cases with 1 and 2 antennas, overall, the radio wave strength is as strong as the theoretical value. That means we don't have to worry about the impact of fading. So we have been able to prove that we can construct a very effective communication environment indoor. Next is the relationship between distance and throughput. This is the data measured in a gymnasium. This is a basketball court, and CPA is traveling from one corner to the other, and this is the video. At the corner, downlink was 1 giga, and it travels diagonally. It is 15 times 28 meters. That's the size of the court, so there's 32 meters measurement distance. 450 megabps is the throughput that's measured. That means within the diameter of 32 meters, we can construct a good area. In Tokyo, in a detached house, it typically have 110 square meters in size. So this environment can cover up to 30 houses in Tokyo. We can do this indoor. So I think this is more than sufficient in constructing a good communication environment. And there is a concern around body block by human body. And in the actual experiment, we have learned that this impact is very limited. With 2 antennas, it is almost impossible to block the radio wave. So there is virtually no impact for the indoor use. I just talked about throughput. The UE that we are using has some constraints. We are being able to use uplink of 200 megahertz. If we can use 400 megahertz with MIMO layers, 2 MIMO layers, this is the theoretical value. So this is the champion data, but in downlink it's 2 giga and uplink is 840 megabps. That is the estimated throughput based on the actual data. So we have been able to prove that this can be achieved in reality, which is more than sufficient throughput. In exhibitions, we often emit millimeter waves to demonstrate how it can be used. This is one of them. It is using real haptics. The controller is on the back of CPU through millimeter wave, through DAS, through a base station. There is the actuator. That's the configuration. And we ask the visitors to distort a potato chip. And this can only be achieved with low jitter. But this was achievable. In exhibitions, it's crowded. We have various different devices. But still, we were able to prove the feasibility of this solution using millimeter wave. This is the final slide. This is a takeaway for you. So the last resort, the key solution is semi-DAS. I believe I was able to prove the feasibility for indoor usage, and this is just a recap of some numbers I've already mentioned. The reputation of millimeter wave is something I mentioned in the beginning, and I have done a sentiment analysis. Up to 2023, positive sentiment only accounted for 27%. The majority was negative. But last year and this year, when we analyzed the sentiments, positive opinions accounted for 53%, so that's the majority. And when we look at 2025 alone, it accounts for an even larger proportion. So I hope you can deepen your understanding about the feasibility of millimeter wave, and I'm sure that you're now convinced. So please post about the feasibility of millimeter wave so that we can achieve 100% positive sentiment around millimeter wave. and I need to promote this DAS. So if you're interested in using it for demonstration, please reach out to us using this address, and please download our catalog from the QR code. Thank you for your kind attention. Thank you very much, Dr. Miyata.
Next, we hear from Mr. Inoue from KDDI, who is the General Manager of the Advanced Technology Promotion Department at the Core Technology Division. We also hear from the Hanawa-san from the KYOCERA, who's the head of the Wireless Network Development Division. They are to discuss the latest situation of the millimeter wave utilization through innovative wireless repeating technology. Today, together with KYOCERA, we developed a innovative wireless repeat technology. So I'd like to share with you the technology between two of us. So first, I'd like to talk about the current status and the challenge of the millimeter wave. Today, the focus is on the quality improvement with regards to 5G now that it has already passed the initial stage. And for the high-speed, high-capacity communication in future, 5G or the millimeter wave is essential. You understand that the 400 megahertz wide band is utilized for high-speed and high-capacity communication, but the radio wave is with high directionality, so it is very weak against the obstacle. For expanding area, as operator, we need to increase number of the base stations, but it means high capex, and also we need to secure the land for installation. So those are the challenges. In order to address the challenges, we are developing innovative wireless repeat technology. The idea is to construct millimeter wave network in an autonomous manner in mesh so that the efficient expansion can be done. So there are three major elements as shown on the slide. Working with KYOCERA as KDDI, we developed this repeater. With this, antenna tuning is not going to be needed, and the installation become easy. And also, backhaul line is not needed, meaning low operation cost. So Hanawa-san from KYOCERA is to talk about the specific of the technology aspect. I am Hanawa. I'd like to give present explanation. Now, the inside of the repeater, starting from the essential. The repeater of the KYOCERA dynamically switches donor services during operation through software control. Conventionally, the repeater had fixed donor and the service. But with the new KYOCERA repeater, they can be switched through the software control. And this enables the autonomous area construction and the autonomous route switching. Starting from the autonomous area construction, so first, the repeater will search 360 degrees to select the best beam or optimum beam. And that surface will be used as a donor surface, and the remaining surface will be used for donor. So search and the selection will be done autonomously by the repeater. And also, multi-hop is possible with the repeater. With multi-hopping, the connection from repeater to repeater will be possible. And with the autonomous area construction with 360-degree search and the multi-hopping, combining the two, network in mesh can be constructed. The advantage of the mesh network is, as shown on the slide, even when the route is disrupted, the disruption is detected instantly and the route can be switched again in an autonomous manner. Another strength of the technology is the following. That is integrated mutualization. Conventional repeater had independent equipment for donor and service, which were connected. But in our case, donor function and service function are integrated, leading to a mutualization. And only one cable for power is needed as a connection, making the easy, quick installation possible. So the key technology behind is the isolation establishment technology. With this, the leakage waves between neighboring antennas can be reduced, and the high isolation performance enable high-quality communication. So securing isolation was a challenging thing. And another key technology is the heat releasing technology. You can see the video there. Antenna is arranged so that we can see a void inside, and so that the heat is released in an efficient manner. So with those two technology of the isolation establishment technology and the heat dissipation technology, we're able to achieve a high performance. And I'd like to hand over back to Inoue-san for the explanation of applications. Thank you very much, Hanawa-san. Now, I'd like to share with you an example of the usage of the repeater. Please look at the left-hand side of the slide. This is our first use case in Nishi Shinjuku or West Shinjuku. So we installed 20 of the repeaters at the street lights and other locations and enhanced the millimeter wave coverage from 33% to 99%, which allowed a 2.1 gigabps for the download load maximum. On the right-hand side, this is the example case. We worked with the JR at the Shinjuku station. So when train comes to the platform, the network environment changes, and then in response to the change, the automatically the optimal route was selected by the repeater, and we were able to verify that that actually did occur. And this is another example in relation to the Osaka Kansai Expo. We installed 3 repeaters in the venue, specifically at the Expo Arena, and also at Water Plaza and near the pop-up stage. We installed 3 repeaters there and compared the station before and after the installation, and we found out that the the traffic increased 8 times. And we were able to reduce the cost by 80%, and the installation work was completed only in a day. And we measured the last day traffic, and the volume or traffic increased 8x. And at one point, there also was the increase of 12x. And another new endeavor that we did at the expo. On October 3, there was a music festival hosted by a Wakayama prefecture on a Wakayama Day. So there was a music event featuring a well-known artist. And at the time, we conducted demonstration of 4K high-definition video broadcasting, leveraging the expanded millimeter wave area. Specifically, we installed a millimeter wave terminal onto the video camera, and utilizing millimeter wave repeater, we uplinked the video. Our camera is a small one, so we were able to enjoy the flexible capturing of the image, leveraging the technology. Now I'd like to show you a demonstration so that you can feel the power of the millimeter wave terminal. So I'm now showing the Netflix video. On the left-hand side, that's the sub-6 terminal. And you can see the circle to show the progress. That shows the progress of the downloading. 150 meg to 300 meg is the speed of the download. It's not slow, but the right-hand side shows the millimeter wave terminal or device. You can see that in an instant, it caught up with the sub-6. So I think only 1 second for one episode. You can see the great performance of the millimeter wave. But the millimeter wave comes with the challenges other than the network, one of which is the penetration of the devices that can handle millimeter wave. Only the 9 of the model can handle the 9 millimeter wave, so we cannot claim that the adoption rate is high. To overcome the situation, we have an idea, and I'd like to share with you our future outlook. I'd like to turn to Hanawa-san. So about the future outlook. So today, working with KDDI, KYOCERA is now working on development of the mass production model of the repeater, aiming at the global market. With this repeater, we are aiming to work with the both Japanese and international operators. With this repeater, KYOCERA is intending to contribute to the utilization of a millimeter wave both in and outside of Japan. And KDDI, utilizing the repeater jointly developed with KYOCERA, we are to expand millimeter wave network. Specifically, we will contribute to enabling the high-speed downloading at the high speed or at the congested station like a venue, so that we can develop use cases which can take advantage of the added value from the millimeter wave, so that we can communicate the value of the millimeter wave to the end users. Lastly, from 28th of October, we will have a summit, and we will have a demonstration at this KDDI summit, so that the user can experience the greatness of the millimeter wave. Let's work together to spread millimeter wave in Japan. Thank you very much, Inoue-san and Hanawa-san.
Now, lastly, we would like to have presentation from NTT DOCOMO. Ms. Mariko Kihara, who is the head of the radio wave, in charge of radio wave and radio wave planning office at Management Planning Department at NTT DOCOMO. Thank you very much for introduction. My name is Kihara. This is the last session of the day, so please allow me to speak for about 15 minutes or so. Now, in 2040, in 15 years, what will be the communication traffic? According to MIC's Radio Wave Study Group report, AI, metaverse, and new services are expanding, and therefore there will be information explosion. So by 2040, in comparison with the level 2020, there will be as much traffic volume, which is 348 times greater than the level in 2020. Now, in order to support the communication in this information explosion age, millimeter wave will be a very important technology. There will be a high band, that is the millimeter wave, that will be the center of the communication. So how we can leverage this will determine our fate of the communication industry in Japan. In the spectrum that we are allotted with, we do have very wide band in millimeter waves. If you look at the LTE and 5G, and if you have the carrier aggregation, there will be the total of the 6.6 gigabit per s speed available. Now, in order to roll out millimeter wave network, there are many issues, however. We do have some pains. For example, on the left side, this shows millimeter wave and LTE and sub-6 gigahertz. And when we look at the 2 weeks worth of data that was processed by the base station that can accommodate all these three. And actually we found that only 0.4% was millimeter wave. This is just an example of a particular base stations in Tokyo. Now, you can clearly see that the underutilization of millimeter wave despite of its attraction. In order to use millimeter waves, we need to have these three columns. You have seen the same three pillars in other presentations. We need to have base stations, we need to have use cases, and terminals. In order to solve issues for these three elements, we need to have some specific approaches. So let me discuss what kind of approaches we are taking at NTT DOCOMO. First, regarding the issues related to base stations, we heard many different technologies related to base stations today. We also have some specific activities. Millimeter wave tends to travel very straightforward and therefore can be blocked. If you try to have the same base stations as if, just in the case of, like in the case of sub-6 gigahertz, for example, you can't have the same coverage. Without destroying the design of the buildings or the architecture, we can come up with different antennas like on-glass antenna. And also different types of other antenna design to allow more flexible location of antenna. And also for repeaters, we plan to use the millimeter wave dedicated repeater systems such as the static reflectors or RRS reflectors. These approaches can expand the availability of millimeter wave. Area expansion is still developing, but using these different approaches, we intend to expand the coverage of millimeter wave. Next element is use case. In case of millimeter wave, we have very prominent strengths, which is low latency and high volume. And smart factory or auto driving are some examples of the use cases. But today, I would like to focus on one of the promising area, which is medical field. This is a case of Tokyo Women's Medical University, and there we transfer the 4K images transferred between two locations to support one surgery operation. And based on the high quality, high definition image, the remote site doctor can instruct or give a fast real-time decision. Now, working with Kobe University, we established a remote surgery proof of concept by connecting two locations through a 5G mmWave. This can be applicable for surgery in remote locations such as remote island. And also, maybe some very difficult operation require a collaboration of physicians or surgeons who are currently in different locations around the country, but that would be possible with this kind of approach. Last aspect is terminal. As I said earlier, mmWave use cases is not something that is directly available or used by the end consumers, but rather that probably will be mostly used in industrial situations. However, when the information explosion is to occur, we have to use mmWave to support that. That means smartphones that you may have should be able to support it. However, today, mmWave supporting terminals or phones are quite limited. We want to have more people to have such a terminal. For that to happen, what is necessary? The answer is to have people actually experience the amazing performance that only mmWave can provide. And as a venue to send out the appeal, we are focusing on stadiums. Places like Eiji Arena or national sports stadiums, we have been installing mmWave base stations. In those venues, we want people to actually experience mmWave firsthand. One example at National Sports Stadium, we are using Sony's 5G mmWave supporting radio communication equipment, which can provide fast image transmissions at high speed and low latency. I'm sure you go to a stadium in order to experience this amazing sports activities in person. But if you go to the stadium at the same time, you may miss a slight change of the facial expression of an athlete or a musician. It will be wonderful if you be there and experience the activity in person at the same time. You can enjoy the expression on the face of those performers. Another example is Eiji Arena. Here again, we have been installing mmWave base stations. In the past, you were not allowed to video recording, but recently, producers actually encourage fans to capture the videos or even send such a video. With mmWave, you can actually capture the video and share that with your friends across the globe. The other day, we made a press announcement. In February 2025, there was a Samsung Galaxy Present TGC in Aichi, Nagoya 2026. I'm sorry, that will be next year in February. And in the Samsung booth, you will be actually experience the mmWave first hand. So we want to promote and drive the widespread of such a terminal. But for that to happen, we have to work with partners in the same industry. Especially millimeter wave accommodating terminal means investment. It's not easy. And also probably consumers need to spend a little bit more money to buy such a terminal. So if you are with me from any government, please consider supporting such terminal manufacturers who are considering manufacturing and designing manufacturing millimeter waves enabled terminals. Now here's my summary. We need 3 approaches to promote millimeter wave. First is to support the base station installations by technology to expand the coverage. Second is to showcase the attractive use cases. A third is to expand the usage of terminals through in-person experience. Through these efforts, we would like to drive the adaptation of millimeter wave, and I do hope that you will join the team. Thank you very much. Ms. Kihara, thank you very much. With this, we close the programs of the day. Once again, thank you very much for making presentations and also helping us organize this event.